So first of all, I'm going to talk about how you find the limit when you have the delta x in the equation. That little triangle thing represents delta, which represents change in x. You're going to treat delta x like a variable. So it's one whole thing. You're not going to plug anything for the delta and plug something else in for x. When you plug something in, you're just going to plug in what you get for delta x. Like whatever that number is, you plug it in just like that. So let's look at some examples. Even though it represents the change in x at this point, we just have to talk about how you solve it. You don't really have to do anything with the delta x at this point, like figuring out what it means. So I know that delta x is approaching 6. So because that's delta x, I'm just going to plug in a delta x for 6 there and a 6 there. So I would get 2 times 6 plus 6 squared, which would be 12 plus 36, which is 48. Alright, this one's very similar. Delta x is approaching 2, so for the delta x I plug a 2. Notice that there is an x there, I just don't plug anything in for an x. So I'm just going to leave it as 2x minus 3 times 2 plus 5. So that's 2x minus 1, because that's the minus 6 plus 5. And it's okay for our answer to have an x in the problem. Alright, on this problem, I can't plug a 0 in for delta x because that would give me a 0 on the bottom. So that means I need to do something else. I can't really factor it, but I can square it, which means I'm trying to simplify. So that would be my first step. Out here to the side, I'm going to square this for us. Anytime that you have a binomial that you have to square, you're going to have to use FOIL. You write it out twice, and you FOIL it. So we'd start off with delta x times delta x, which is delta x squared. It's not delta squared x squared, just leave it as delta x squared. 2x and delta x is 2x delta x. It's not 2 delta x squared. These are two different variables, so you cannot combine them. So then you get another 2x delta x, and then the last is 4x squared. So that leaves me with delta x squared plus 4x delta x plus 4x squared. And now I'm going to go back to this problem, and I'm going to plug that in for that part of it that is squared. And then minus 4x squared over delta x. Now that goes away. And I would like this delta x to go away, but I can't just get rid of it. The delta x has to be in common with everything in the problem. But what you can do is you can factor out a delta x on top. If you're factoring out a delta x out of delta x squared, you're left with delta x. If you factor a delta x out of the 4x delta x, you're left with 4x. And then on the bottom, you just have a 1 because you have your delta x. That'll go away, and then so you would have a 1 on the bottom. Then you can plug your 0 in for delta x, and your final answer would be 4x. Last kind of problem of this type again, you're going to think about all the different kinds of problems that we have. And basically, I'm going to need to get a common denominator here. It's kind of weird because it's got a delta x in there, but it's the same process. So when I get a common denominator, I already have a 1 plus delta x on top, so that's a 1. And then I need to make this be 1 plus delta x on the bottom, which means I multiply by 1 plus delta x on top. I need to be really careful here because that minus in front of the 1 goes to both pieces. So that makes minus 1 minus delta x. And then we still have our delta x on the bottom. Alright, so then that leaves us, that's 0. And we have negative delta x over 1 plus delta x. And then this is like over delta x, so I'm going to times it and flip it. Fortunately, that goes away. And then we end up with negative 1 on top, 1 plus delta x on bottom. Plug in your 0, and then you get negative 1. Okay, I'm going to go ahead and give you 2 try problems related to that concept. Do not stop the video at this point. There are going to be 2 more problems at the end of the video related to the next concept I want to show you. Alright, the next concept, whenever we're doing limits algebraically, there's one more kind of concept, and it's called thinking about the graph. Personally, this one is my least favorite. It's easy, but it's something that you really have to think about whenever I think about what kind of problem it is. I really have to consider the way the graph looks, and I have to consider asymptotes and those types of things. Now, when you're thinking about the graph, this particular kind of problem occurs when you have a vertical asymptote. So we're thinking about problems where your graph might look like that, or your graph might look like that, or your graph could look like that. There's more possibilities, but that's the main 3 kinds. If I talk about the limit as I approach 0 on all of these, on the first one, it would be undefined because we're going towards infinity, we're going towards negative infinity. On the second one, that would be infinity because they're both going up. On the third one, that would be negative infinity because they're both going down. Pretty much on thinking about the graph, which is your last resort on these problems, those are the 3 possibilities and those are the 3 answers. It's either undefined, infinity, or negative infinity. And you just have to figure out which one of those graphs it looks like to decide what the answer would be. Now, whenever you have these kinds of problems, normally it's a rational function and you would have something on top and something on bottom. Whenever you're doing these types of problems, after you factored everything and looked at it, the bottom where it would equal 0 would be where the vertical asymptote is. So in this problem, whatever would be left, that would be where the vertical asymptote would be located. And because this is to the first power and there's not some number here, this particular problem, as I approach the vertical asymptote, the limit would be undefined. Now, if when I work out the problem, I get something on top and then something squared on the bottom. Actually, it could be to the 4th or to the 6th, any even power. Then my answer is either infinity or negative infinity. And the reason is because the bottom makes the sign the same on the bottom, and then whatever the sign is on top, that makes the graph go towards that thing. Now, whenever you're doing problems, it's possible that you could be having wholes and asymptotes, and I just wanted to remind you, if you have something like this, there would be a hole at x equals -2, and there would be a vertical asymptote at x equals -3. The way I know that, x plus 2's, they go away. Whatever term goes away and is still not there, that's where a hole would be located. And most of the time there is a limit whenever there's a hole. And then with vertical asymptotes, that's where you look at what's left and what's on the bottom. If I were talking about the limit as x approached -3 of that problem, then I would know it was undefined because there's a vertical asymptote and because x plus 3 is not to an even power on the bottom. Okay, let's look at some examples. Alright, there's nothing to do here. I can't plug in a 2. I can't factor and do the conjugate and do a denominator and all those things. So this one must be thinking about the graph. It's always the last resort. I look at it. I realize that it's not raised to a power on the bottom that's even. It's just an x minus 2 on the bottom. I know that 2 is the vertical asymptote because 2 would give me a 0 on the bottom. And because there's nothing else to do, and because I know that that's not squared on the bottom, I know that this one would be undefined. Now, if you weren't sure and you absolutely wanted to do something else, you could make a little chart for both sides of 2. Maybe you would want to know what's going around 0 and 1 and what's going on at 3 and 4. You could plug those numbers in. If I plug in a 0, I get 5 over -2. If I plug in a 1, I get 7 over -3. If I plug in a 3, that would be 11 over 1. If I plug in a 4, it would be 13 over 2. And then I would graph it. So here's my 2. 3 is way up here at 11. 4 is down further, and I know it's going to have that little curve, so it looks like that side's going to look like that. Okay, 0 is at -5/2. And then 1 is not quite at 5/2 because that would be a little bit smaller, so and because it's smaller, I know I did something wrong because I know what this answer is supposed to be. If I plug in a 1 there, I actually get a -1, so I knew that wasn't right. Sorry about that. Let's rewrite that. That's going to be a 7 over -1, which is -7, which is really far down here. And if I connect that, it would go down, and I notice that both of those are going towards different places. So that's why, as I approach 2, that would be undefined. Again, you don't have to do that graph or that table, but if that's helpful to you and if you actually do your math correctly, then you could figure out sort of what that graph is doing. Alright, this one, again, there's nothing really to do. It is easier to draw the table and the graph on this one because it's easier to plug in those numbers. But because I realized that, okay, 0 would be the vertical asymptote, I know I'm approaching the vertical asymptote, and it's a squared term on the bottom. That thing that I'm approaching is squared on the bottom. I know that this is going to be either infinity or negative infinity. And then I just need to look at the top. The top is positive. So that means my answer is going to be positive infinity. Alright, on this one, if I plug in the -3, I would get 0 on the bottom. So I'm going to go ahead and factor. I'm not going to work out the whole process. I'm hoping that at this point you can factor. And if not, you need to just let me know and let me help you. X plus 3's go away. Looks like there's a hole at x equals -3, but because there's an x plus 3 left on the bottom, that means that there's not a hole, there's actually a vertical asymptote. So this problem has a vertical asymptote at x equals -3. That's what I'm approaching. X plus 3 is not squared, so I know that this means that that particular graph, they're going to go different ways at -3, so the limit would be undefined. Again, I need to do something here before I just say what the answer is. Looks like I can factor it. It factors easily into x minus 3 times x minus 3. Since that's 2x minus 3s, I'm just going to go ahead and square it. I know that because that's a squared term on the bottom and because I'm approaching the vertical asymptote, and this is thinking about the graph, I know that my answer is either infinity or negative infinity. I'll look at the top, there's a negative on top, so the answer is negative infinity. And here's the last two problems that I want you to try. Both of these relate to thinking about the graph. So in total, there should be a total of 4 problems that you will have tried for tonight's homework.